Welcome, this is Dr. Hisham Saeed. This video here is the first part of a small series on construction scheduling. And this video here is on project sequencing. So let's first kind of have a big picture on how construction schedules are developed. So we're seeing here a 5-step process. So we have to first define the work activities or project activities. You have to estimate the duration of these activities. You have to find the logic or the sequence between these activities. And then you have to represent all of that in terms of a project network. And then do activity or scheduling calculations, is what we call the critical path method calculations. From previous lessons, we learned about WBS, work breakdown structure, and the outcome of that is a list of the project activities and work packages. So that's kind of covering the first step of scheduling. Also in a previous lecture on estimating, we use RS-means in the lectures, but also part of the data of a company, beside cost estimates, are production estimates. So they are really tied together. So when you do the cost estimating exercise, you also do kind of production estimation. So you imagine how it would be your construction means of methods, and that will lead you to unit costs and also production rates. And that will be used to calculate the durations of the activities you identified from the WBS. So technically here we have only, like we cover already 2 steps of the process to produce time schedules for construction projects. And this means that we need to move on to the 3rd step, which is kind of sequencing these activities and identify the logic between them. So if you're like me, I like puzzles, and sequencing is a puzzle. I really like this exercise of trying to sequence things and put them in order. And the thing here is you need a little paradigm shift when you look at a project in order to develop its sequence and logic. So Sherlock Holmes is, well, I mean, a fictionist kind of character, but I quoted here a very related wisdom, you can say. So most people are, if you give them steps, they will be able to follow these steps to the end goal. But not many people, if you give them the end goal, they kind of bring up the sequence or the steps that lead to this goal. So this is called what Sherlock Holmes called it, the power of reasoning backward. So it's not backward reasoning, it's reasoning backwards. So you're reasoning in a backward fashion. So you put the end goal clear, and then you start backtracking on what leads to this end goal, and then what leads to this task before the end goal, and keep going like that. So it's basically you start asking questions, what activities precedes this activity? Once you're done with that, you move to these predecessors and you start asking the same question. What activities precedes these activities? And you keep doing that until you reach a point where you say, that's it, that's the beginning of the project. So sequencing the work here depends on a lot of factors. We cover some of them, some studies, and some people describe it in a different way. But here I'm showing 4 main categories of factors that kind of affect the way of sequencing different construction activities. So the first one is physical. So how the building elements are related, and even how the work tasks are physically related to each other. So as an example here, this is a foundation footing, and then you have the masonry wall, but the connection between the slab on grade and the masonry wall is different between this case and this case. So the slab on grade here is kind of connected, or the same monolithic kind of pour, so it's the same concrete pour of the slab on grade and the kind of the ring beam. So this is kind of a beam that's embedded in the wall. And then you have a different course or different layers of masonry on top of that. Here, there is this disconnect. So the slab on grade here is disconnected from the ring beam or the embedded beam in the wall here. So this means that when you start sequencing, in here you have to pour that slab on grade at some point of time early in the project, because the upper part of the wall is dependent on it. You have to finish this pouring or placing the concrete here. After placing the first segment of the wall, and then you'll be able to install or place the second segment or the upper segment of the wall. But here, you have more flexibility now. It's up to you to pour or to place the concrete slab on grade while you're doing the wall, or even after you finish it, after you completely finish the wall here. So they are now disconnected. So the logic here, the sequencing, is different between these two cases, because the different elements here, the slab on grade and the wall, are connected here. Here they are disconnected. As the second factor here is the availability of resources. And when we say resources, general construction, it refers to anything you need for construction. So money, equipment, people, material, anything. So the availability of this anything resource for your construction affects how you sequence things. So here, this is an example of the 49ers Levi Stadium at Santa Clara, California. And you see here a lot of steel need to be installed. But of course, the most critical resource on site of such size are cranes. So you don't have a lot of cranes, you don't have a lot of lifting capacity or rigging capacity to put simultaneously all of this steel. So you don't have like 10 cranes. So what they did is they split the stadium into quarters, and every quarter is kind of covered by a crane. So they can now logically they can think of, instead of working on all 4 quarters at the same time, initially they think, I have 4 quarters, how many cranes I have, and then they can start now sequencing. So if I have 1 crane, then I have to do the 4 quarters in a series. If I have 4 cranes, I can do the 4 quarters and simultaneously at the same time. So here you have to think, like, the major resources that control your sequence are heavy equipments, cranes, tower cranes, also money. Like, you always have to think about how much cash I have as a contractor I can burn until I get paid by the owner. So money is also a big resource. Labor is also a critical resource, especially if you are a union contractor. So you're dealing with union workers. And union halls, or the place where you hire these union workers, have a limited number of members. So they're member-based, and you have to account for that. You can't, if you have a huge project that requires, let's say, 300, 400, 500 electricians, and it's in a city, and if you are a union contractor, you have to stick to the union, the project labor agreement or the bargaining agreement you have with the union. And if they can only provide 200, then you're stuck. You have to phase your project and sequence it in a way that will account for that. So you can't work on every spot in the project have an electrician. You have to split the project and phase it and sequence it in a relaxed way. The next factor here is safety and quality. So you have to sequence the activities in a way that reflects first the safety of the workers and also the quality of the work that you installed. So safety here, an example, tower cranes, or when you install heavy things on the roof, you can't have activities happening below the roof or around the building for safety reasons. Things are falling, hitting, even if you have a hard hat, just a very hazardous environment for those working below or around the building. Quality here is always this debate between should you install the flooring first or you do painting first. And the answer always like the common answer, it depends. It depends on the flooring type. So are you installing hardwoods or ceramic or carpets? And every one of these requires different sequence or its own kind of consideration for qualities and also different ways of installing the flooring. So some hardwood comes already pre-finished. Some require a lot of sanding, so you put them in place and you sand them and you protect them. So sanding here is a lot of dust, and if you have painting, you have to think: should I paint first before the dust or after? So dusting here is not it is always something you have to think about. How much dust is created by an activity, and how this dust or waste of activity is affecting the quality of the activities around it. Also, when you do painting, you have a lot of prep work you have to do before painting, like sanding. So when you sand the painting now instead of the floor, the hardwood, you have to think about the sanding creates a lot of fine dust. And I mean, whatever you do to protect the flooring, you have to account for the sanding and dust out of the paint, sanding the paint. So there is no clear answer, but you have to check your project. Every project might come with a different sequence. But you have to understand also like the requirements and the consequences of that. So if you do the painting first and then you do the flooring, you have to accept now that your painters will come back and do more touch-up than usually what is expected. Because when you just look at the flooring here, you use heavy tools and hammers to install things. So it's normal, like with a swing, you will damage the paint and the wall. So safety and quality and accounting for that in sequencing activities is another critical factor. Surrounding environment, which is environment here covers weather, economical, political. So you see here, this building is being built and the project is continuing even with snow and rain. So you go into winter accounting. So when you do the schedule, you want to do most of the outdoor work before winter. So once you have the shell, you can actually work inside the building and not be impacted that much by the weather outside. So it's a very critical factor in cold regions. So when the winter hits, your project is not just freezing, literally. You still can do some progress, and your schedule can be move through your schedule and not being impacted by weather. Another example here is economical reasons, or the economical environment of the project can dictate doing things a little earlier. So for steel structures, at some times, it's always people pay attention to the prices, and the steel price fluctuates, goes up and down. And if you think that the steel prices will go up because of, we know about tariff, this is 2020, the US and China trade war. So at some points you see that you're sure that the steel prices are going up. So in this case, you have to set up your steel structure a little earlier. The shop drawings and procurement is a little earlier and more aggressive in your schedule. So when you do sequencing, also the activities, it's not about which one comes first, but even that relationship between doing A first and then B, this relationship you can define an attribute we call lag, which is a time buffer or a delay. So when you finish A, you don't do B right away. As a logic, you enforce a lag between them. So for example here, like the famous example is concrete. So when you pour the concrete, depending on what type of element you're doing, is it a slab on grade, is it a foundation, is it a column, or floors, slabs and beams? Of course, the more horizontal, more flexural the member is, the more lag and curing time needed. So the longest cure time is for slabs and beams compared to columns and then foundation. So you have to account for that. I cannot just right away jump next day on that wet concrete and start installing things, or I cannot remove the formwork of beams and slabs the next day. I have to wait. That wait period is just the time. So you don't have a resource accounted for that. So it's just a time period, so you represent that as lag. Unless you have a resource that does specialized queuing, then this is an activity in itself. Another thing you have to pay attention to is when you put the logic, you create that logic or sequence, don't create infinite loops. So if B depends on A, and then C depends on B, and then A depends on C, so this means that this is an infinite loop. And always, when you do that, softwares will detect that and will tell you. But just be aware of when you do create the logic on a paper or an Excel sheet, be aware of not or avoiding that closed loops or infinite loops of activity logic. So we can practice the sequencing of this simple example. This example here, we've seen it in the previous project when we started creating, when we practiced WBS. That's kind of now the activities list from a possible WBS. And the exercise for you is to sequence these activities. So I'm representing activities by the code here. So the idea now is you start backward. So you start from the finishing activities, we call, and then you start thinking what activities need to be done before these activities that I'm considering now. So for example, clearing site. To clear the site and deliver this project to the owner, the customer, what need to be done? So here it's 180 and 190. So activities 180 and 190. So 180 is surfacing the road, and then 90 is bridge railing. So these are kind of finish activities in terms of you want to keep them to the end for different reasons. They are dependent on the bridge itself to be done, and also the quality. You don't want to put the road surface and then having heavy equipment with dirt and all of that make it, affecting its finished quality at the end. So it's your exercise. We'll discuss this in the class to continue the reasoning backward exercise. So kind of continue from going and trying to find the logic. This doesn't mean that you can actually do it the other way. You can reason forward. So you start thinking, after I finish an activity, what comes after that? Some people are wired this way. That's fine. But if you want to apply a rule like reasoning backward or reasoning forward, stick to it. So once you start backward, you continue backward until you finish all the logic. Once you start forward, reasoning forward, you continue with this logic until the end of the project. So we're done with the sequencing the activities, the third step of this process of creating construction time schedules. Next video will cover how to represent project schedule networks using bar charts and activity on node. Thanks for watching, and I'll see you in other videos. Take care, and bye.